What is black carbon deposition? What exactly is black carbon deposition? This term refers to the process where black carbon particles settle on surfaces, especially in polar regions like the Arctic. Black carbon, often known as soot, is a fine particulate pollutant created by the incomplete burning of fossil fuels, biomass, and other organic materials. In the Arctic, these particles travel long distances through the wind from industrial areas, wildfires, and gas flaring activities. When black carbon lands on snow and ice, it darkens their surfaces. This darkening reduces their ability to reflected sunlight, a phenomenon known as the albedo effect. As a result, more solar radiation is absorbed, leading to increased warming and accelerated melting of ice. In the Arctic, this deposition happens year-round, but it is most significant during the winter and spring months. During this time, a phenomenon called Arctic haze carries higher concentrations of pollutants. From the perspective of polar regions, black carbon deposition has three main impacts. First, it contributes to faster melting of sea ice and glaciers. This melting disrupts local ecosystems and contributes to rising global sea levels. Second, the accelerated loss of ice exposes darker ocean water, which absorbs more heat. This creates a feedback loop that amplifies both regional and global warming. Third, there are important policy implications. Regulations specific to the Arctic aim to reduce black carbon emissions from sources like shipping, gas flaring, and cross-border pollution. These sources disproportionately affect polar climates. To address these issues, several mitigation strategies are in place. Stricter emissions controls for ships operating in Arctic waters are one approach. Reducing gas flaring in oil-producing regions is another important step. Additionally, international agreements targeting transboundary pollution are essential for protecting these sensitive environments. Understanding how deposition patterns work helps policymakers prioritize which emission sources to tackle first. For visual content, consider showing images of soot-covered ice and shrinking glaciers. Infographics can illustrate the pathways of emissions. Highlighting individual actions, such as supporting clean energy initiatives, can also make a difference. Relatable comparisons, like wearing a black shirt versus a white one in the sun, can help viewers grasp the albedo reduction concept. This way, they can see how black carbon deposition affects the Arctic and the broader implications for our planet.